Hi, my name is Jacob, and alongside with my partners Bruce and Cosmin, we're going to show you today how to make an RC circuit. The purpose of this lab is to show you how a capacitor uses charge on an LED. A capacitor is a device that stores electric charge. In DC, once the capacitor is fully charged, the resistance climbs to infinity, thus blocking the current.
Hello, my name is Cosmin, and today I will be conducting the safety talk about using one of the labs in Seneca College. As you can see to my right, no eating or drinking shall be permitted at any time in the labs, and the safety glasses must always be worn. Right, as you can see, I have the main emergency switch for the lab which we are currently in. To turn the power on, you must lift the safety cover. Ensure that the red button is pulled all the way, lift the safety cover and press. In case of an accident, all the workstations can be shut off by pressing this red button. You know you have done so correctly when the green button turns off. Also, next to the emergency shutoff, there is a telephone which the emergency personnel can be contacted in case of an emergency. On my left side, I have the workstation individual emergency shutoff stop, which can be stopped by pressing on it, and to release and restore power, it must be twisted clockwise. Located in the back of the lab, we have the safety station. The safety station contains a material safety data sheet that contains all the information regarding the different dangerous materials that could be used in this laboratory. To the right, we have an emergency eye wash with a poison control number 1-800-263-1623 in case an external contaminant gets into the eye. Under it, we have a carbon dioxide extinguisher. I'm currently in front of the workstation number 11, which we will be conducting our lab. As you can see here on the table, there is the full materials which we will be needing. First, I'd like to start with the two switches, which are just a piece of copper wire and a piece of aluminum wire, a red LED, a green LED, a 47 microfarad capacitor, a 100 microfarad capacitor, two 1000 ohm resistor, or also known as 1 kilo ohm. Just a quick reminder about that: the color coding on the resistor should be brown, black, red. Okay. Going on, we have the breadboard. To the left of it, we have two alligator clips. To the right of this is a multimeter, which we will be using, and right above it is the DC power supply, which will be providing us the 12 volts required.
My name is Bruce, and beside me is a schematic of the RC circuit we will be building in today's lab. As you can see, there are many different symbols on the schematic. Here is the 12 volt voltage source that we'll be using, the switch, 1 kilo ohm resistor, the red LED, the 100 microfarad capacitor, the 47 microfarad capacitor, switch number 2, and 1 kilo ohm here, and last is the green LED. The first step in building our RC circuit, we will turn on the individual power source for the workbench we'll be working at by pulling the lever down. And then we will turn on the power source for a circuit by pressing this button. Now, you want to make sure that the current is high enough so that the green LED here lights up. And then to toggle the voltage, you use this dial. But first, we will connect our multimeter here, turning it on, and setting the dial to 20 volt maximum. And then hooking up the leads from the multimeter to the leads from the power source by putting red to red, or positive to positive, and black to black, or negative to negative. So we should get a reading on our multimeter. Right now it's at 11.25 volts. So I'm just going to turn up the dial until it's about 12 volts, and that's pretty close. Second step in building our circuit, we will be using a breadboard to connect each of the components in our circuit. We'll put the breadboard down on the workbench and begin from there. Now to create the first part of our circuit, we will be using the switch, a 1 kilo ohm resistor, and a red LED, and we will be connecting them in series. First, going back to the breadboard, we will put the one end of the switch in a port on the breadboard, then connect the 1 kilo ohm resistor by putting one end into the first row, connecting it to the first switch, and then with the other end put it in another row like so, and using the red LED we'll put the longer side, which is the positive, facing towards the resistor, and then we will place the one end into the row there and the other end in a different row. And that is the first part of the RC circuit. Next step of building the circuit, we will be using both capacitors, the 100 microfarad capacitor and the 45 microfarad capacitor. First, using the positive end of the capacitor, which is the longer metal wire, we will put that in the same row as the end of the red LED, and then the negative wire from the capacitor we will put in a row on the other side of the breadboard. Then, using the 45 microfarad capacitor, we'll put the positive end in the same row as the negative end of the 100 microfarad capacitor, like so. And then we will put the negative end in another row over here.
Moving on from where Bruce left off, we're going to build the final leg of our circuit. First, you're going to need the green LED. Then you're going to need to get your 1K ohm resistor. And finally, the switch. Keep in mind that you're going to be connecting all these components in parallel with the second portion of your circuit. Grab your LED and get the shorter negative end and connect it to the negative end of the capacitor, like so. Then you're going to want to grab your 1K ohm resistor and connect it to the positive end of the LED like this. Finally, you're going to get your switch and connect it to the resistor. Now, while you're building, keep in mind that you want to periodically press down on your components to make sure that they're connected properly, like so. Okay, so now that we have our RC circuit built, we're going to want to connect the power. So you can get your alligator clip and connect it to the negative leg of the LED. Then you get your negative lead and you connect it like so. Now, before I hook up the power, the red LED is gonna flick on real quick, so watch. You catch that? And now to connect the switch to the red LED is gonna turn on the green LED, like so. So what just happened was when I connected the power, current went through the red LED, lighting it up, and then charging the capacitor. Once the capacitor was fully charged, the current stopped, and the red LED went out. When I touched switch number 2 to the red LED, the current was discharged from the capacitor, which flowed through the green LED, causing it to light up and use up the charge. That concludes our presentation on how to build an RC circuit.